Alright, so till that point we have already discussed in detail in the last class. So today we'll start with rest of the flags which are exclusively only in 8086. Fine. So let's start with the first one, which is OF. Fine. OF stands for overflow flag. This OF stands for overflow flag. Fine. So if I have to explain you, if I have to tell you what is overflow flag is, before I go in the description, I'm giving you two examples. Just tell me what will be the answer in that case. Let's have two 8-bit numbers. Okay, so these are two numbers. Just take it like this is case 1 and this is case 2. Tell me what will be the answers. Quick. What will be the answers in case 1 and case 2? Quick, quick. And just keep this thing in your notebook. Do note these two examples in your notebook because this is very good for understanding of overflow flag. So what is the answer in the case 1?
Sir, 0, 0, 0, 0, 0, 0, 0 and 1 carry bit.
Okay, in the case 1 it is all 0 and there is a carry in the out. And what will be the answer in the case 2? It is 1
1.
1 0 1 1 1 1 0 and there is a carry out. Is that correct? Case 1 and case 2, are they correct? Okay. Now look at the cases here. Fine. If I tell you, just use your logical thinking, which one do you consider as overflow flag? Which one is giving us the condition where some overflow is taking place? Let me write in detail. Alright, which one will be the condition for the overflow? Just have a logical understanding about it. Is case 2 or case 1? Which one is more close to the overflow stuff? Case 1 or case 2? Anyone? See, what we have is
Case
a
one.
which one?
Case one.
Yeah, definitely. And how come you finally finalized your answer as case 1? How come? On what basis?
Sir,
On
we are
what?
adding one on highest number.
Haha. Okay. We are adding something to the highest number. Maybe it 1 or maybe it be 2. Fine. So what it is giving us by adding something like 1 to the highest number of 8 bit, where it is landing us to the, it is landing us to the initial state of the 8-bit number, or it is the lowest number back to the answer. So see what is happening here. Suppose we are having the maximum number or the biggest number, and still we are adding 1 to it. Fine. What it will be giving us? It will be loading us back from where it all started. Fine. This is the condition of overflow. We are adding something to the maximum number. Are you getting it? The bucket or the tub is already full. This is already full, but still you are adding something to it. Fine. So what will happen? The water will keep coming down. It will keep start overflowing. This is what we mean by the overflow. The same condition which is getting reflected here, but the phenomena is totally different. Fine. Where it will lead us back to? It will lead us back to the zero state. But in case 2, what we are having here, this is normal addition. There are two numbers and they are getting added. What we are getting output, what we are getting out is the carry flag. This is not the case of overflow, this is the case of carry flag. Fine. But in case 1, it is the case of overflow flag. Fine. So if I have to tell you in the writing what you need to write in the overflow flag is used to indicate when, because flags are the indicators, we have already discussed, when an arithmetic overflow has occurred. Arithmetic overflow has occurred in an operation. I believe you are getting what an arithmetic operation is, this particular thing. Fine. So if you want that kind of condition to be indicated, the point is, if you want that kind of condition to be indicated, that when overflow occurs, when this condition comes, you want your system to identify, you want an indicator, you want a signal which will tell you overflow occurs. Fine. So in that case, what you need to do is you need to set overflow is equal to 1 already. If you want to use the conditions of overflow, in that case it will give you that condition that overflow is occurring. Fine. So in that case, the overflow flag, it would be set so that the program can be aware of this particular problem, and we can create decisions to mitigate this signal or error. Alright, so this is the operation of your overflow flag. Alright, is that clear? Is that clear? Overflow flag? Is that clear?
Yes, sir. Yes, sir.
Don't worry, we'll have a quick revision before we end this class. Fine. But for the time being, is it clear from the example I have given you? Because whenever you describe a flag, always go in booleans. Explain it in terms of boolean. Alright, so come to the second flag. Second flag we have here is DF. DF stands for direction flag. DF stands for direction flag. Fine. So now just think of something. What direction are we talking here? Flags associated with direction. Just think of this thing. What direction it can lead us? Or what direction are we talking about right now? A direction related to the flag. Think logically, think. You know the answer. Anyone? Okay, I believe you guys are not able to understand about the directions. Okay, so in the bit pattern, if I give you an example, so how many ways we can read this bit pattern? Just tell me. There is this bit pattern on your screen. How many ways we can read or write this? Either if this is right and this is left. Fine. Either we can go from left to right or we can go from right to left. There are only two directions we can have. Am I correct? Are you getting my point? In order to read a particular bit pattern or a data, there are only two ways. Because if that data is stored in a register, either you enter from this side or either you enter from this side. Fine, either you read from left to right or you read from right to left. So basically, there are two directions we are having, either left to right or right to left. But particularly when we are talking about a flag, there is one thing which is associated with this. What we are talking? We are talking about specifically about this. So direction flags are associated with the reading of string. Now the direction of reading the string will be decided by us, whether you want the string to be read by left to right phenomena or you want a string to be read like right to left phenomena. This is what is given in the direction flag. The way you want your direction flag to be working. Fine. Is there any benefit of doing this kind of thing? Do we see an application of this particular thing? कोई बताएगा मुझे? Do we see an application? Anyone? Alright, I'll tell you the application, but before that, just try to understand what can be done in this. What are the instructions and how to be done. So when it is set to 0, the direction flag, it is again a flag, it will be having two values, 0 or 1. So when it is having the 0 value, you can do that by the instruction which is called CLD. CLD stands for clear direction flag. So if it gives you clear, clear means the direction flag will have the 0 value. In that case, what is going to happen? In that case, what is going to happen? Left to right reading will takes place. Left to right reading will takes place. When it is set to 1, that means STD is the command. STD is the command. STD stands for set direction flag. Set direction flag, and set to what? 1 value. In that case, the reading can be from right to left. Alright, so what happens in that case? The way we are talking about string, what could be the application point of this direction flag? कोई बताएगा कि application क्या हो सकती है? Have you seen a movie named Dawn 2, in which Arjun Rampal was hacker? Have you seen that? And they have shown a clip where he's having this light matrix keyboard, and by that on the DOS console he is doing some hacking by entering the password. So that password in the like in the old times, 8086 was when it was used in the systems. So the moment you are actually putting a password and the previous state of the direction flag is 0. So first thing first, whenever you are putting a security condition, you just need to see what is the pattern you are putting already in. If direction flag is 0, that means you are setting left to right. Fine. And that moment, when the default setting is left to right, the processor will read from left side to right side. So let's say I entered the password my surname, which is DEV, and the default setting of reading is 0, direction flag is 0. That means the processor has to read from the left to right. Fine. First capital D, then E, then V. Fine. But I'm very smart. Somehow I changed the setting to 1. Fine. Now just have a look what is going to happen over here. In case of df is equal to 1, the reading will take place from right to left. Agreed? So now the person who is going to enter the password is not known to the setting which I have already changed after setting the password. Fine. So let's see what we are going to do. So if somebody knows my password, what is going to happen? They enter the D value. So what it is going to give? What it is going to give as a flash message? Access denied. Why it is giving the access denied? Because in the previous case, the reading was from left to right. But now what the reading pattern is? Current state, the reading pattern is from right to left. So in that case, if you are entering the D value, the D value will be compared with the V. And what value? The sky values of D and V will be compared. Fine. If the value, these value, the hidden algorithm inside is the value will be subtracted. The value sky value of D will be subtracted with the sky value of V. Fine. If you are not getting a null value after the subtraction, fine. If there is not a null value after the subtraction, what message are we going to get? The message we are going to get is access denied on the first key. Fine. So what finally we have to do? So finally, what we have to do? We have to reverse the password. First key should be V. Then V will be compared with V. Null character will be generated. That means okay. Then second key E will be compared with E, null character. Then D will be compared with this. So this is the way. In the past, you were having the first level of security even by having the DF direction flag in the action. So just imagine in 1978 they've already thought about the reading of direction of string from left to right or right to left. And for doing just this thing, the engineers at that time, they used to take a lot of money just for these two instructions, CLD and STD. They create a framework by which they actually provide you the security. So is that clear? Have you understood what direction flag is or what it can do? It is simply the left to right, right to left processing of a string the way you want. The instructions are CLD and STD. Is that clear?
Yes,
Is that
sir.
clear, everyone? Although it is not explained in the books in that way, it is my own thing I created for you to understand. So next is what we have is interrupt enable flag. Next is interrupt enable flag. All right. And this is also called IE. But when we talk about interrupts in 8086, if we talk, there is only one interrupt which is called NMI. And NMI itself says that it is non-maskable. That means what? It can't be avoided, it is unstoppable, unavoidable, something like this. But still I'm saying interrupt enable If I'm having only one hardware physical interrupt in the 8086, what am I going to enable or disable by this? Huh? What should I be doing with this interrupt enable flag when I'm having only one flag and I can't enable or disable it? This is having the highest priority simply. Fine. So what happens here is the interrupt is altogether a different category. Interrupts are of two types. At one type, it is called hardware interrupts, which are available in the pin diagram that you can see, that you can connect any device or sensor in the circuit. On the different side, we have software interrupts as well. Fine, software interrupts are totally dependent on the programmer. The programmers can create a number of software interrupts. Fine. If let me get back to hardware interrupt first. Hardware, like we have already discussed in RS 8085, trap, RST 6.5, 5.5, 7.5, and now we have NMI. These are the hardware interrupts which are visible, which are available in the pin diagram, and you can connect anything. But after that, we have some software interrupts like RST0, RST1, 2, 3, 4, 5, 6, and last one is RST7. Fine. These are the what you say, the facility inside this 8086 that programmer can create its own software interrupts. So this particular interrupt enable flag is only associated with the software interrupts, not in the type of hardware, because we have only one hardware interrupt and it is again having the highest priority. Non-maskable, neither we can enable nor disable. Fine. So what we have here is, it is simply non-maskable. So this is basically related with the maskable interrupts, which are basically your software interrupts. Fine. So if I have to write in your definition, fine. Interrupt enable flag, it determines whether or not the CPU will handle maskable hardware interrupts. Maskable hardware interrupts. Just take it like maskable interrupts. Hardware is not always needed. Maskable interrupts, you can skip it. Fine. So what happens if interrupt enable flag is equal to 1? That means it is for maskable interrupts. Maskable interrupts will be handled. This is what you will write. Maskable interrupts will be handled. Fine. And when it is 0, not set, maskable interrupts will be ignored. See, this is the case we are having. Even the maskable interrupts, they can be enabled or disabled. If interrupt flag is set to 0, it will disable all the maskable interrupts. It will simply disable all of them. None of them will work. Fine, but still, if we are going to use them, we have to put if is equal to 1. Fine. So what is the handling means? I say they will be handled. Handling means what? Handling means all of these interrupts which are shown here, RST 0, 1, 2, 3, 4, 5, 6, 7, they all will be having a priority. Whenever we talk about interrupt, there is one thing which is always associated with the word priority. Fine. So when I say handling of what? Handling of priority. Fine. So what's going to happen is RST 0, it will be having the highest priority. and RST7, and there can be more than that also, it will be having the lowest. That means what? If there are two interrupts coming at the same time via RST0 and via RST2, so RST0 will be taken care first because it is having the highest priority. RST2 will be handled a little later because it is having the middle level priority. And if something is coming via RST7, it is having the lowest priority. It will be dealt in the end. सबसे बाद में उसकी handling होगी. So by handling means handling of priority. Which one is having the highest priority? It will be acknowledged first, then all other in the sequence. Fine. So is that understood? Interrupt enable flag. It is only for maskable interrupts, disabling and enabling. If enable, it will be handle what? Handling of priority. Is that clear, all of you?
Yes, sir.
Yes, sir.
All right, better. So the last flag we are having here is, which one is the last flag? So last flag what we have here is called trap flag. Fine, and don't confuse with trap of 8085. In 8085 was an interrupt. Trap flag is a flag in 8086. They are altogether a different category. Fine. So just before we go towards trap flag, just tell me one thing. If we want to have a debugging approach, there is a bug in your program and you want to do the debugging, and hardware we call it troubleshooting. Fine. How do you want that debugging to takes place? Because this is let's say a full program written in the memory, although memory has segments, but still, if we are going to debug, how do you want a debugger to operate? How do you want a debugger to operate? If I take reference from compilers as well as interpreters, fine. So compilers was like it reads the full program at once and provides the list of errors in the end. And what interpreter does is it goes instruction by instruction, and like you people know that line by line. Okay, so which one do you want? Which approach do you want when you want to find the bug in your program? A compiler approach or interpreter approach? While doing the debugging, which approach you will follow? Full program at once, or reading the program instruction by instruction, or line by line? Tell me what approach you will prefer. You are finding a bug in your program and you are going to get paid very smartly for that. How do you want that? Which one will be more effective for you? Which approach?
Instruction by instruction.
Interpreter.
The approach of interpreter. Fine. Definitely, this is what is the job of the trap flag. Fine. Now, what trap flag gives you? Trap flag gives you an operation. The moment you put trap flag is equal to 1. Fine. This is basically the first job of debuggers. Those who are working in the field of 8086 based design, the first instruction, the moment they are going to debug, the first instruction they will be having in their console is TF is equal to 1. They will be putting TF is equal to 1. What it will be activating? What it will be activating is, it will be activating the step through. A step through means, or if I tell you in the simple language, single step execution. This is also called single step execution. So what's going to happen is, a trap flag permits the operation of a processor in single step mode. Right? If such a flag is available to us, or available to the debugger, they can use it to step through the execution of a program. Fine, or you can write down when TF is set to 1, a system is in single step mode. What is it is going to do? It will execute one instruction and then stop. Fine. Now after stopping, what is going to be what will be the next thing? After being stopped, the contents of the registers and memory locations along with the instruction can be evaluated or it can be examined by the debugger. If they are correct, the debugger can move on. It can provide the instruction, okay, let's go to the next. It will simply press the go to next button, and what is going to do, same stuff is going to happen. Next is it will again execute the instruction. It will stop, and the contents of register, memory location and the opcode will be examined. If they are correct, it will go like this. Fine. So it is simply like a cycle. When trap flag is equal to 1, it is simply activating the single step execution, basically dealing with the debugger or troubleshooting operation so that we can check what is problem in the program. Is that clear? Is that clear, trap flag? All of you? Is trap flag clear to all of you?
Yes, sir.
All right, then let's get back to today's topic. What we started with the revision of the previous flags we discussed, and we moved on from that to the starting flag for today's session was overflow flag. So overflow can be understood by a condition like this, where we are having the maximum number already loaded into it and we are still adding some more to it. So it finally gives us overflow condition, which leads us back to its initial state. This is the initial state. Fine. So if you want that kind of condition to be identified, you need to use the overflow flag to indicate. It has to be 1. Once it is 1, the system will be programmed to indicate, or it can be creating some signal so that we could be identified by that there is an overflow in the arithmetic calculations. Next we were having was direction flag. Direction flag basically deals with the direction of string, left to right or right to left, reading of string, at which direction we are going to read it, from left to right or right to left. The instructions for these are CLD. CLD stands for clear the direction flag. It will set to 0. That means the reading will be from left to right. In the next case, when we are setting it 1, the instruction is STD, that means we are putting it to right to left. That reading direction is right to left, and what we are particularly going to read in this is the string. The application, like we've already discussed, the password security methods were first associated with the direction flag. Fine. What next we have here is interrupt enable flag. Fine. So interrupt enable flag basically deals with only the flags which are associated with the maskable ones, because what we are having is only one flag in 8086 which is hardware, and this particular flag is what? It is non-maskable. We can't have it. Fine. So this particular interrupt enable flag deals only with the maskable interrupts. Fine. What are the maskable interrupts? The software interrupts that can be generated by the programmer in the program. All right. So if if is equal to 1, the maskable interrupts will be handled. If it is 0, they will be simply ignored or simply disabled. By handling, what do we mean by handling? Handling of priority. Highest will be handled first and the lowest will be handled in the last. This is what interrupt enable flag is. Fine. Next is, in the last we have the trap flag. Trap flag is basically for the debuggers. We want the debuggers to step through into the execution and check where are we having the problem. So in order to execute the single step execution, we have to put TF is equal to 1. So when TF is equal to 1, a system will work in the single step mode and it will execute one instruction and then stop. The contents will be examined, and if they are correct, the memory location and the contents will be examined, the registers as well as the instructions. If they are correct, they can be instructed to go next. If not, new instruction will be loaded, and this is how it will be going to help. So is that clear, all of you?